Hello and welcome. Today we're going to talk about what is a microservo, how to connect it to an Arduino board, and explaining the code that will be used to control the microservo. A microservo is a small and compact type of servo motor commonly used in hobbyist and DIY projects to provide precise control over small mechanisms or components. It consists of a motor, gearbox, and control circuit and can rotate to a specific angle or position and hold that position. Microservos can be used for precise control and positioning of small mechanisms or components in a wide range of applications, such as controlling small model vehicles, moving robotic arms, controlling cameras, providing steering or throttle control for remote-controlled vehicles, actuating small mechanisms in DIY projects, and controlling the position of small sensors or electronic components. For today we will be using the Tower Pro SG90 microservo, a small and inexpensive motor that can be used in a variety of projects. To use the SG90 microservo, you'll need a few things. First, you need the servo itself, and you'll also need a microcontroller, such as an Arduino Uno board, to control the servo. Finally, you'll need a power supply to provide power to the servo. As you can see, there are three colored wires: red, black, and yellow. Connect the red wire to your power supply's positive terminal, the black wire to the negative terminal, and the yellow wire to a digital output pin on your microcontroller. After you have connected the microservo motor to the microcontroller, you will need to use a code to be able to control the microservo. Here is a simple example code. Inside the red box it shows the include line at the beginning of the code imports the servo library, which includes pre-written code to control servo motors. The next line creates a servo object called myservo. This object will be used to control the servo motor. In the setup function, the myservo.attach 9 line attaches the servo to pin 9 on the microcontroller board. This tells the microcontroller which pin the servo is connected to, so it knows where to send signals to control the servo. In the blue box it shows the loop function of an Arduino program, which controls the Tower Pro SG90 microservo using the servo library. In this particular loop, the myservo.write function is used to move the servo to different positions at 1-second intervals. The first line, myservo.write 0, sets the servo to move to the 0-degree position, which is all the way to the left. The delay 1000 function then tells the microcontroller to wait for 1 second before moving on to the next line of code. The second line, myservo.write 90, sets the servo to move to the 90-degree position, which is in the middle. Again, the delay 1000 function causes the program to wait for 1 second before moving on. The third line, myservo.write 180, sets the servo to move to the 180-degree position, which is all the way to the right. The delay 1000 function causes the program to wait for 1 second before returning to the beginning of the loop and starting again with the myservo.write 0 line. These few lines of code sets up the basic framework for controlling the Tower Pro SG90 microservo using the Arduino IDE and the servo library. With a few simple steps, you can start using microservos in your projects. Whether you're building a robot or a remote-controlled car, microservos can add precise motion control to your project. Thank you for watching.